Well, thank you very much for having me here. When I first came up with this session was before Umbraco 7.6 had changed from orange to teal. So you can pretty much imagine clouds in any color if you think about it long enough. So we'll rename the session Painting the Clouds Teal instead of orange. A quick session overview. This is an experience sharing session. So I'm going to talk about the processes and challenges that we faced at Crumpled Dog, the lessons we've learned, and there will be some live demos, hopefully. There's also a good chance I might accidentally reveal some API keys. I hope not, and the video guys said they can definitely blur them out if that happens, but hopefully it won't. I may also have to cancel some of my colleagues' builds, but it is a Friday afternoon, so the chances are they probably won't be that busy, but we'll see. So a little bit about me. I'm Technical Director at Crumpled Dog in London. We're a Gold partner based in London's Silicon Roundabout. I'm also a Umbraco MVP, and I've been very lucky to be an Umbraco MVP for 3 years. I'm an active community member. I do answer questions on the forum and attend events and speak at meetups and that type of thing. I'm also a Umbraco core contributor, having created the API for the image cropping in 7.2, and also, as Runa said this morning, did quite a lot of work on Umbraco 7.6 with the value converters. In fact, it's taken a year to get those where they are. So I'm a package hacker. I've made a few packages. Some have been successful, some haven't. I've also contributed to quite a lot of other people's packages and fixed stuff and helped them with build automation and that type of thing. Crumpled Dog, a quick bit about what we do. We're a full-service creative agency. We've actually been around a very long time, and since 1965. Obviously, it weren't called Crumpled Dog then. And I said we're a Gold partner. We do a lot of big projects involving Umbraco and integration in platforms like SAP, and also even sort of platforms involving satellites and set-top activation. So lots of projects that involve integration. But this talk is about DevOps, or at least our journey into DevOps, and how we wanted to automate as much, if ideally everything, except for the actual development. Unfortunately, we haven't got robots that can do that. For this talk, the majority of this is really about the package element of DevOps, but the other parts will come in as well. So talking to agencies over the years, and also from our own experiences, I've sort of identified there are 4 levels to DevOps within the Umbraco agency. The first is level 1, which it looks a bit like this old machine. This is where on a local machine, or yes, sometimes on a server, people actually pull the code directly from Bitbucket or GitHub, or maybe they don't even have source control, but we're not going, that's level 0. We're not going to talk about that. And then they build it somehow, probably in Visual Studio. They may even use Grunt or Gulp or something like that. Often, I've seen these tools installed on production servers so that they could pull the code and actually build it there and then on a production server, which is a crazy thing to do, but a lot of people do it. They then manually edit config files, putting connection strings and other settings or anything like that manually into the files on that production server, and they pray and hope that everything is right and the system just runs. As I say, it is a ton of stuff. Node.js is another thing that's often installed on servers, which is a whole another security risk aside from anything else, as well as just bloating the servers up. They then will either create a zip file or copy via IDP or somehow get it into the website application folder on the server. So that's level 1. The next step up from level 1 looks something like this. This is level 2. So it does actually drive. So someone from the team normally learns how to execute MS build from the command line. And this allows them to create a build.bat. And I've seen a lot of build.bats in solutions. And Umbraco has one, in fact. So you run a build.bat, and it will run MS build and do some other stuff, and will maybe even create a zip file because they may have learned how to use 7-zip from the command line as well. And then they will obviously do the same thing, put it onto the server. The next level up is level 3. This is quite a big change. This is normally when people introduce a product called TeamCity into their infrastructure, which is a build server. When we first started using TeamCity, I absolutely was in love with it. It was revolutionized everything we did. People's code was getting checked and built and all failed, and we knew about it straight away. But as time went by, I started to spend more and more time fixing TeamCity than actually doing anything else. And it can be fully automated with TeamCity, but most of the time it isn't. And yeah, just more and more time fixing TeamCity rather than actually building stuff. It does provide continuous integration, but it does require your own servers, at least currently. And it requires the operating system and other tools such as Node.js to be kept up to date. So somebody has to go in and maintain that server and make sure that it's up to date. All the tools that are necessary have been installed. Another thing is that you can't you actually, until V10, which is the most recent version, I think, you couldn't actually script the configuration. It had to be done through a UI. But with V10, they have actually introduced the ability to script configuration for TeamCity. But it also doesn't have a deployment engine. And because TeamCity doesn't have its own deployment engine, a product called Octopus Deploy came along and sort of sold itself as the deployment engine for TeamCity. Although it is perfectly possible to use TeamCity for deployment as well. But Octopus is very popular in this sphere. So level 4. This is cloud-based build services. So AppVeyor, Visual Studio Team Services. These are two of the, certainly in the Umbraco area, two of the most popular cloud-based build systems. They're both build and deployment engines. They have both things within there. They're cloud-based automation systems, continuous integration, also continuous deployment. No servers are required, which is a big change. So everything is in the cloud. There's no need to maintain any servers. And one of the best things about these services is the images they're running on or the systems they're running on will always be up to date with the latest tools. So if you suddenly need to do a build in Visual Studio 2017, which is something we actually happened just this week because somebody had written some C#7 and it was all fine on their systems, but it goes to the build server, oh no, I can't do it. They just changed the image from 015 to 017, commit it, and then the image is brand new with Visual Studio 2017 on it. It took about 10 seconds. And yeah, I said they both contain deployment engines as well as build engines. So deployment methods. So this is the release element of the DevOps cycle. At the very basic level, and it doesn't always go in line with the development and build services, but at the very most basic level, people manually copy files via FTP or remote desktop. Sometimes they automatically push files using FTP or blobs or anything like that. But Microsoft has a built-in deployment engine built into Visual Studio or built into MS Build called MS Deploy, which is a very powerful deployment engine, much underused, but it is used by Visual Studio Team Services and AppVeyor. There are other things like Octopus Deploy. One of the cool things about Octopus Deploy is it uses NuGet packages for its packaging, so it's very easy to change versions between different ones because they're all wrapped up into a nice container. And you can use things like third-party agents. So, for instance, AppVeyor has a third-party agent, which is a piece of software that you actually install onto the environments. And there are some advantages, like if you've got really crazy firewalls that can't have stuff coming in, it can literally like pull deployments in. So it's like a way around not being able to use MS Deploy. It does other things as well. So our story. It wasn't a quick change. Back in 2012, we were definitely at level 1. By 2013, I think we had definitely learned how to use MS Build. Level 3 by 2014. And then we actually made it to level 4 only last year. In the middle of 2015, we hired a new tech lead who had been working somewhere where they were pretty much stuck at level 2 and had been forever. But he decided we needed to really sort ourselves out and make sure that everything was working as it should. So we had a real impetus for a really big project he was leading to make sure that we could get all this stuff to work. So we chose Appvea to build and deploy all of our environments. How many people have actually heard of Appvea? How many people have used it? Okay, just one. Wow. 2, okay. Well, Umbraco, amongst other open source products, use Appvea for builds. And the reason they do that is because it's completely free for open source projects to use Appvea. So a lot of Umbraco packages also use it, and many other .NET-based projects use it. It's basic. There's another system called Travis CI, which has existed for a long time in the Unix world, which is also a build service for the Unix-based world. And Appvea is very similar to that in the way it's configured and built, except it's running on Windows servers. So what was our dream back in 2015? It was no on-site infrastructure. I really didn't want to have to spend time maintaining operating systems anymore. It was at the front end, because we have a quite decent-sized front-end team who are doing all this trendy gulp and grunt stuff and changing frameworks every day of the week. So we need to make sure that both the front-end side of things, which is almost as complex as the back-end side of things these days, could also be supported and treated as a first-class citizen, and they could both be built and tested. The one thing we really, really, really wanted was the consistent and reliable versioning, because we have a client who takes care of their own deployments, and we ended up spending so much time supporting them because of an issue where they had missed a DLL or something. We couldn't really work it out, and it took so much time trying to identify exactly what it was that was out of sync, maybe a CSS file. So we wanted consistent and reliable versioning across all assets. So we're talking about CSS, JavaScript, C#, DLLs, views, everything. And we wanted, obviously, continuous integration for our QA team to be able to validate new code commits. We also wanted it to be ultra easy and quick for senior developers and technical managers to make production or staging any type of deployments. We wanted everything to be able to talk to everything else. And when we first came up with this list back in 2015, it was quite hard to think about how we could achieve all of these things and how they were all going to come together. So how do we do it now? So our source code is managed by Bitbucket. Most of it's using Git. We do still have some Mercurial repositories, which is why we're still using Bitbucket, because we can't move those to GitHub. Bitbucket's perfectly fine. So we moved all of our processes to Appvea, both the build process and the deployment process for all environments. That's production, staging, and development. And all of our environments are hosted in Azure in a mixture of different things, from web apps and virtual machines. So for instance, development server will be a virtual machine. As a production environment, it's probably going to be a web app. We wanted all of our monitoring, so our post-launch monitoring, to be handled by New Relic. And we wanted everything to be automatic. And on that day, I did actually celebrate by uninstalling TeamCity. So I did actually have a little party as I clicked the uninstall button and said, no more do I have to fix you. So how does this all work? How many people have used Slack? How many people have not heard of Slack? Okay, cool. I did this little graph in America, and a few people came up to me afterwards and said, what's Slack? So, okay, so your code gets pushed into Bitbucket. Appvea gets a webhook sent to it, and it tells it to pull. So it pulls the code from Bitbucket, and then it does a build, and then it does a deployment. It also sends a webhook to New Relic, and we'll have a look at a bit more how that works. And both of these send a webhook to Slack. So a Slack channel for a particular project will have messages about every single thing that's going on within the project. So it will know about build failures or build successes, deployment failures, etc., all within one channel. So basically, it's all reliant on webhooks. So branches, transforms, and build configurations. So the way we've done this is that each build configuration has a matching deployment branch. So within Git, we'll have a development branch, we'll have a staging branch, and a production branch, as well as feature branches. So each branch configures AppVeyor to build the correct build configuration for the target. So the staging configuration will make the correct transforms on that particular branch. We use XSD transforms for all configuration changes. So built into MS Build are XSD transforms. How many people have used those? No one? OK, cool. We'll have a look at those. And we use those both for web config, which is native to MS Build, but also for other config files. Because in Umbraco, there are other config files that also sometimes need transforming. For instance, Umbraco settings.config. So you have to do something a bit special to transform those, but that's all built into MS Build. And we also have our deployment branches are restricted rights. So only certain people can push to those branches, which is part of Git. So only somebody who's authorized to make a production push can actually do that. So we're going to do a little mini demo, just have a look at the branches transforms. It's not really a demo. So build configurations are in Visual Studio are kept here. So for instance, in this demo project, we have a production branch, staging branch, and then debug. And these are not branches, these are the build configurations, debug and release build configurations. So for instance, yeah, this is the one that's open. Is that big enough? So this is a transform on the production configuration, which is just to turn the models builder off, the models builder API off. It also sets a new relic name and sets debug to false. Often these are quite big and they'll normally contain connection strings and loads of different settings, app settings. So this will basically transform using XDT this file based off the branch saying you need to build in production mode. Does that make sense? Yeah, good. OK, cool. So the branches themselves, this one here is a simple one, just got a development and a production branch. And there's actually just one change that needs to be made on the production branch, which is committed once, and then Git knows that's the change to that file. I'll have a look at this in a bit more detail in a moment. But that one change is this configuration. So this configuration tells AppVeyor which one of those to run in, basically. So it tells it that on the production branch, I must be running the production configuration, which means those transforms get applied for that build. Yeah. So AppVeyor, a little bit about AppVeyor. It's a build server and deployment engine in the cloud. I said that already. Each configurable by a single file committed to source control, which is the AppVeyor YML. So all changes to your build configuration are also source controlled. Every build is a freshly spun server. And this is a very important difference between TeamCity and AppVeyor, for instance, is there's never any debris. So when your build begins, it's actually a brand new server that's been provisioned in the cloud just for your build. And once your build's completed, it's disposed of. So that server's lifetime is literally for your build. This means there's never any debris that's going to be causing you issues, so old files that have been left over. You can cache certain folders. So if you've got, for instance, node modules, if you've got a lot of node modules, that's actually quite a big process to download all of those node modules. So you may say, I want to cache that. So you just, at the end of the build process, AppVeyor will create a zip folder of that folder and keep it. And then at the beginning of the next build, it'll just unzip that at the very beginning. OS images are always up to date. You can choose different OS images just by a single line configuration. So if you want to build in Visual Studio 2013, you can. And the images contain a ton of stuff. They contain loads and loads of different tools that have already been installed. This is already out of date because this is 2015. But they contain a ton of stuff that's already been installed and configured correctly. And anything that you need to do is documented within the documentation. So it also includes, as well as Visual Studio, all the front-end stuff, so Node.js and even Python and stuff like that. You have total and complete control to do anything you like. That virtual machine is yours for the period of its existence. Obviously, there's not really any security concerns because it's only there for a limited time. So you can change anything. You've got PowerShell and Command Shell. You can change anything you like, which allows you to customize your process to do anything that you wanted to do. Oh, I should say it starts, actually I'm not sure in euros, I think it's in dollars. It starts at about $60 per month for private projects. There's no limit to the number of projects, but number of build workers is the limiting factor. So depending on how many projects you've got on, you may find you need more build workers than one, which is how many projects can be built at a single time, at the same time. YAML. Has anybody ever heard of YAML? Okay, a few. So YAML is a markup language. Originally, it was supposedly meant yet another markup language. But then somebody thought it would be really, really clever to make it a recursive acronym. So YAML just means YAML ain't markup language, which just goes round and round and round and isn't really that clever. But it is really simple, and it's what we use to configure AppVeyor. There's also a really good Visual Studio plugin called the YAML editor, which just makes sure that the formatting is correct if you install it in Visual Studio. So appveyor.yml or YAML. This configures AppVeyor build agent for your project. It contains almost all of the settings. It can contain them all, but there's a few things like if you have any particular credentials, you may not want them to be included in the file. So in which case, you can use the variables to encrypt those values. There are many, many steps within the build pipeline. And this allows you to hook in, at any point, different command or PowerShell to customize exactly what's going on to exactly what you want. It has built-in assembly patching so that DLLs are always correctly versioned. So this will change the assembly info.cs file to make sure that the version number is correct, so the DLL trackable version is right. And we're going to have a little demo of this one. I did show it briefly. This is a very, very simple project. It does have an Umbraco in it, and it does have a front-end gulp process. So this is a very simple example. The version number of the build's up here. This will be the actual build number. And this is the image I was talking about. So when we need to change it to 2017, we just have to change that 5 to a 7. These are the cache folders that we want to cache. Then the important configuration mode over here. Then these are some environment variables that we've created. So I just scroll down too far. This is the version suffix. So we want our builds in this mode to be suffixed with alpha. And we've got our artifact name and which branches we want to build on. So we may not want certain branches to build. We may want, you can do wildcard matching here, regex. So this is for tags. But we may want to build our feature branches. We may not want to. So it's all configurable in here. And then within the install step, this is where you can install software or wherever you want. This is doing things like installing gulp and Bower. It's also updating NuGet. And then this is the assembly patching. So this is just saying find anything that matches this assembly info, and it'll patch with these different variables. Then the actual build script. And we'll have a look at these in a bit more detail in a minute. So these are all the different stages of the build itself, right down to notifications, down the bottom here. which is the actual sends the Slack notification. Yeah. So our build scripts, there's no real correct way to do this. So out of the box, you can actually literally go into AppVeyor and use the UI and just say build this project, and it will just build the Visual Studio project automatically without you doing any of this. As I say, there is a complete UI where you can start off really quickly and get it running. And then once you've got that right, you can actually tell it, and you decide you want to switch to AppVeyor YML, you can export the AppVeyor YML to start with and then continue from there on. Once there is one in your project, then that takes precedent over any UI changes. That's it. There's no correct way. The way we've ended up, we have a mixture of commands, PowerShell, and actually some Node.js. It's evolved over time, and the reason we have Node.js is because it's very convenient. There's a lot of modules on NPM that do some pretty useful things. So, for instance, I want a YAML parser because I want to automatically update a version. Oh, there's a Node module that will do that for me. So just install it. We're pretty happy with the process as it is, but it's going to evolve, and we can probably make it simpler. We wanted our CI builds to be semver-ish. This is because the ish is because NuGet, until recently, until version 4, which just come out, wouldn't support the hyphen here, the dot. So semver would have a dot here, not a hyphen. But for Microsoft-based compatibility, you have to have the hyphen until NuGet 4. We wanted tagged commits on the production branch to create release builds. So we wanted it really, really simple to just go, right, this is ready. This commit here is going to be the version 1 release. So the developer or whoever's doing the deployment just creates the tag on that particular commit, and this will trigger out there to go, right, this is a production build. I'm going to version everything version 1.00, and I'm going to run the production build. So it's ultra simple. We also wanted build versions to be auto-incremented following release. So once the technical manager has made that release, we want to make sure that the next build is version 1.0.1 alpha something or other. So to make sure we don't end up with duplication where we've got version 1 builds that have actually occurred after the release, which is something that used to happen quite a lot. So the build scripts where we currently are. We have this AppVeyor client dependency version. This is a Node file. This one actually sets the client dependency version number to match the build number. So we know that there will never get any problems whereby the user, the editors are loading their front end, their back ends, and they've got some JavaScript that's out of date. We know our build number is always going to be absolutely unique, and it's never going to be used before. So we set it into the client dependency config file for that build, and that ensures that that doesn't happen. Version patch, AppVeyor version patch, again, a Node file. This sets the version within the package JSON. So this package JSON is used by Gulp builds to know their version. So then what happens is there's a task within Gulp that adds a banner to the top of the JavaScript files and the CSS files. And because this script's been run, that version will match the C# version and the build version. So the banner will always be identical. So we know that that CSS or JavaScript matches those DLLs. So everything is going to be consistent and trackable. This PowerShell script format just does some logic on the existing build numbers to make them semver, i.e. so that the builds come out like this. There's actually quite a few differences. So for instance, this one here, we need to reset the real semver with the dot, otherwise Node doesn't work and Gulp doesn't work. So we actually set a few different environment variables in here for the different, same but different versions that we need to use elsewhere. This is because in PowerShell you can set environment variables, but in Node.js you can only read them, or you can set them but they're only within the scope, so you can't then read them elsewhere. So for anywhere we wanted to set an environment variable, we have to use PowerShell. Build mismatch. This is one that we added fairly quickly after we first started down this road. And this is whereby somebody has accidentally merged staging branch into development. and the deployment end, the build has gone through, and it's actually run the incorrect configuration transforms for the branch. We didn't want that to happen, so it ended up with a staging deployment that had development configs and all messy. So this just checks to make sure they match, and if they don't match, it actually aborts the build, so we get a build failure notification, and we can find out who's merged incorrectly. And it's very easy to abort builds and interact with the build engine itself within PowerShell. Check release version, another PowerShell script. This one checks to see if the build has been tagged, or the commit has been tagged, and if so, it will then set the right variables, say this is a release build. Version bump, this is the one that actually post a production, a tagged production release, will then check out the development branch and bump the version up, so the app there will automatically increase its version. We'll see this in action. And this is a PowerShell that runs Git to actually commit that back to the development branch. And this is just a simple command that actually runs the MS build. And this one. And then we already looked at AppVeyor.yml, which is the master of the build process. Tests. So one of the key things in automation is making sure that the code that's building is correct. So obviously there can be build failures because somebody forgot a semicolon in JavaScript or a squiggle or whatever it might be. So within AppVeyor, as well as running the build process, assuming the build process succeeds and it doesn't get aborted, it will then run the tests. This can run both C# and front-end tests, so using Jasmine or something like that, so we can run both. So this will fully test the project using the unit tests that are built in, and as I said, any front-end tests as well. Umbraco has about 4,000 of these, I think, so if you actually watch Umbraco build, the test part take quite a long time to finish. So deployment using environments. So deployment is a stage in the build process. So you can actually, in your AppVeyor.yml, you can add a deployment section and you can tell it to run MS build or do something like that. And if you do that, then your deployment will actually be part of your build process. And will just occur. As in AppVeyor, if you want to use the deployment engine, this is called environments. So once the build is complete, it will offload the process of deployment to the deployment engine, or it will trigger it. So once the builder gets to that stage, it says, OK, environment, production, you've got this package to pick up and do whatever you want to do with it. And that can be done automatically, or it can also be done manually. If you're doing that, then the deployment is asynchronous. So once the build's completed, the build agent's free to do another build for somebody else. The deployment engine is separate and will just do its thing. Notifications and webhooks. So the deployment engine, as well as the build engine, also has the ability to trigger any sort of notification and fire any webhooks. And we'll have a look at an example of that in a minute. You probably can't see that, or maybe you can. So this is just an example of a deployment log. So this just shows this is a production deployment, and you can see that the builds are all correctly tagged that are deployed to that environment. So New Relic for performance monitoring. How many people have used New Relic? How many people have used a different performance monitoring tool? Okay, not many. Wow. So monitoring is the final stage of DevOps before the cycle starts again. So this is once you've gone live, how do you manage performance and how do you monitor it and actually make sure that what you've deployed is faster or better than the version before. There are other tools other than New Relic. So there are things like Datadog, AppDynamics, and also Microsoft has its own tool now called Application Insights. But New Relic has application performance monitoring, or APM. It also has browser performance monitoring. So this actually injects some JavaScript into the very top of every page that actually provides you with detailed performance monitoring on your front end. So your render times, your load times, all of that. And that's actually real-time data. and then you can compare the two. Synthetics, we actually only use synthetics for very basic ping monitoring to make sure the domains are up, but you can actually do pretty much sort of regression testing with synthetics if you go further into it, so you can actually get it to do forms and all sorts of different things like that to make sure it will then alert you if something was broke. This is the type of graph you get in New Relic, which is just showing you the current performance of your website. So one of our ambitions was to be able to monitor deployment changes within New Relic. And so we set about looking at the New Relic API. So there's a full RESTful API for New Relic. And the one thing we really wanted to do was be able to record a deployment. So when you make a deployment using the deployment engine, we wanted to notify New Relic that version 1.6 had gone live. And that would then allow us in New Relic to compare versions. So we can say, how does version 1.6 compare with version 1.5? And it will show us in amazing detail the difference. But we wanted that to be automatic. So this API existed to allow us to do that exactly. So this is the this is a log of deployments in New Relic deployment, and obviously these are the versions. And with this log of these deployments, we can actually then compare the performance between the two. So we first started thinking about this. We started talking to the AppVeyor team because it certainly wasn't obvious how we could do this. There was an ability in AppVeyor to add webhooks as notifications, but we couldn't quite call the full RESTful API because we needed to have a custom request body. So nicely, AppVeyor actually added this feature for us. So it allows us to actually call the New Relic RESTful API. We have to add a header with our API key. And then we can just put in the custom request body. Is that too small? I can't make it any bigger anyway. These templates are variables that are available to you. So you can just put these in. So you saw it a minute ago on the last slide. So for instance, my name here, or Scott's name here. These are coming from this one here, build.commit author. So this allowed us to, on successful production deployment, push this payload to New Relic, and so it knows automatically that a new version has been deployed. We have a custom dashboard. It's a very simple custom dashboard. What it does is it reads from the DLL, or a specific DLL within the solution, version numbers. So it reads the informational version number, and it reads the file version number. So this tells us that this, even though this is the production site, it was made from build 25 on AppVeyor. And we can go back to AppVeyor, go to build 25, and then go straight to Bitbucket commit, so we can see exactly which version this was built from. In this environment, which is a development environment, it obviously shows us the pre-release postfix. And again, it also has the build number is in here, the same as here. So this allows us to track exactly which versions are running in which environment at any one time, so we can go on staging and know exactly which commit we've got there, and the same for all the different environments. So we're going to have a quick demo time, or hopefully quick-ish. We're actually going to try and make a change, commit it, make sure it goes onto the CI server, tag a release build, and deploy it to production, and make sure that New Relic picks this up. Let's wake these up. So this is the project. We'll have a look at it in a second. So I'm on the development branch. I'm going to make a really important change to this project. So I'm going to push the development branch. And hopefully we will see here it appear up here. So this is, I pushed that to Bitbucket. Bitbucket sent the webhook to New Relic, to Appvea. Appvea is pulling the repository via Git. So while it's doing that, we can just have a look here. So you can see the different builds that have been taking place in the past. So this is a full build history. So you can see that all of these ones on the develop branch have all got the postfix. And then you can see fairly quickly this one is actually a production release. And here, you can actually see here this is a failed one. Should have been, because I cancelled it. So the version number gets set as part of the process, as we saw before. So actually we should see this version number change in a moment. The build time on this is about 4 minutes, well, 3 minutes 45-ish. And this is just in this project I said is a very simple, is a base Umbraco install and some front-end gulp stuff. So it's still unzipping the node modules because there's so many of them. So, assuming that build completes, which I expect it will, what I would do is to make a production deployment. I would switch to the production branch. And while we switch there, I'll just take a quick look in here. I'm just going to reload this. Oops. So here's the single change. So the only change between the development branch and the production branch that has been made is this configuration here. So you can see that the configuration on this branch will be production. And through the magic of Git, that will get maintained as long as the merges are always developed into production. So it will always keep that. And if it doesn't for any reason, then we'll get the build mismatch failure. So this is now into the... Oh, it's already into the .NET part. So it's done the installation of Gulp and Bower and updated all that sort of stuff. So it's just running the front-end build stuff. So you get a full console readout of exactly every step that Appvea is doing. And it can be quite long because there's quite a lot of stuff in there. While it's doing that. So assuming that build was successful, which hopefully it will be in a minute, I would then want to deploy this to production. So I would just merge the develop branch into the production branch, like that. Is the screen going funny? And push that one. And then assuming that's correct, I will now tag this one. And it's important that the tag must be the correct tag. It does do a check to make sure that the current build and the new one are going to match. So I'm going to push this tag. Oh, the really important build already finished. So here we can see we've now got two pending builds. The first one, which is without the tag, and then the actual tag. So the only difference between the result of these two is that this one will be versioned with this specific one, and this one will be versioned with like a pre-release version. So we can actually cancel that one, because we don't really need that one. So let's go to the very bottom there. Once it's loaded, still loading. You can see all the front-end stuff. So this is creating the web deployment package. Right, we're there. So right down the bottom here, we can zoom in here. 500, that sounds a bit extreme. Stop. Trying to zoom to 500%. Ah. I'm just going to reload it. All right. That's going to reload everything. So eventually we'll see it in a minute, but that development build triggered the deployment to this server here, which is the development server from the development branch. So that was triggered asynchronously. And if we look here, the files it actually changed in the deployment were just these two DLLs, the client dependency config, because of course the build numbers changed. So the client dependency config version number will be the same as, will be 40, the same as everything else. And then my special view. So this is the CI site, or the development site. Oh, that's there. Let's go to the bottom. There. So this is where it triggered and offloaded the deployment. So at the very end of the build, it said build was successful, test passed. There's some very important tests in there, 1, 2, 3, and 4. They passed. So everything was good. So offload to the deployment engine, the deployment to the environment, Orange Cloud, best in development. So that triggered the environment to do that. And we can see the change. So hopefully our change made it to CI. So hopefully our QA managers are going to be happy because I've already triggered the deployment. So hopefully this production deployment is nearly ready. Yes, let's just log back in there. So we can see that our dashboard is updated to version 40. So we know that all the DLLs and everything was good, and our CI site has that particular version. So for our production build, there are some sites where we actually have it automatically deployed to production, but most of the time we actually let the technical manager, whoever's doing it, manually just choose and make sure that that final production deployment is the correct one. This is very simple though. So you can see here, because it was a production build, it's actually skipped the deployment to development. I'll go back that way. Deployment. So I'm going to do a new deployment. So this is where I'm going to do it manually. I'm going to say I want to deploy this to production. And this version 0.16 is the one I want to deploy. So that grabs the zip file that was created by the build process, and then uses ms deploy to actually deploy it. Now, ms deploy also does a diff, so it only deploys, as you saw before, it only deploys the files that have changed, not the entire solution. So that's done. So this is our production site. Umbraco fires up. So in New Relic, because we just made a production deployment, I'm hoping that in the deployment section, I'll be able to see the new version because that webhook has been fired off. And there it is. So there's version 0.116 has been successfully deployed and it's been logged in New Relic. So I'm sure it's going to, it hasn't even fired up. It has just fired up. Now we can see we've got our fantastic new changes now live. Our dashboard is good. So you can see in our we've lost all the pre-release stuff because this is the final release. So we can see it's just fired up. So we can see in New Relic the difference already. If we click on change report here, oh, there's no data. So it's already been logged. Everything went as well as it could. Yeah. And I think, any questions? Any questions at all? No? Okay. Thank you.